All right, Venkat, exam time is coming up, but don't you worry one bit. We're going to tackle this together. Let's break down everything you need to know about acids, bases, and salts. Think of this as your secret weapon, your ultimate study guide. Ready? Let's get into it.
Okay, first up, and this is a big one, a super important rule. You see this quote? It's probably the most important safety rule in all of chemistry. Seriously, you just can't go around tasting things to see what they are. So that begs the question, right? If you can't taste it, how in the world are you supposed to know what's what? Well, that's exactly why we have science!
So let's meet our two main players for today, acids and bases. Think of them as two sides of a coin. Acids, well, you already know what they taste like. Think about biting into a lemon. That super sour taste? That's acid. Bases are the opposite. They're bitter. And when it comes to touch, bases feel kind of slippery, almost soapy. You know when you're washing your hands and they get that slick feeling? That's the base in the soap at work. So we have sour versus bitter and corrosive versus slippery. Got it?
All right, let's zoom in on our first character. Section 1, it's all about acids. Pay close attention here, Venkat, because this stuff is definitely going to be on the exam. Let's nail it.
Okay, so when we talk about acids, it's not just one big group. It's more like they have two different families. On one side, you have the mineral acids. These are the heavy hitters, the strong ones, usually made from minerals. Think stuff you dig out of the ground. Then, on the other side, you've got the organic acids. And the name tells you everything. They come from organic things, like plants and animals. Easy, right?
And you know what's wild? These organic acids are literally everywhere. I mean, look at this. The vinegar you put on your salad, that's acetic acid. That zesty flavor in lemons and oranges, all thanks to citric acid. Even milk has lactic acid, and apples have malic acid. And get this, ever been stung by an ant? That little bit of pain comes from something called formic acid. So yeah, chemistry isn't just in a lab. It's in your kitchen, in your fruit bowl, and even in your backyard.
Now, this is super important, Venkat, so listen up. The biggest difference between those two acid families is their strength. The mineral acids, they are strong. We're talking highly corrosive, can cause burns on your skin strong. They're so powerful you have to keep them in special glass or ceramic containers. But the organic acids, they're the weak acids. They're way less destructive, so much so that, we eat them. You'd never drink a mineral acid, but you drink citric acid in orange juice every day.
All right, here's a little nugget of information that might just win you a bonus point on your test. Of all the mineral acids, one stands above the rest. It's sulfuric acid. It's used to make so many things, paints, fertilizers, car batteries, that it earned the nickname the king of chemicals. Pretty cool, huh? Remember that one.
So let's see these acids in action in the real world. That hydrochloric acid, HCl, it's a powerhouse cleaner for really tough jobs. The king of chemicals, sulfuric acid, it's inside car batteries making them work. Nitric acid is what goldsmiths use to get gold and silver sparkling clean. And of course, acetic acid. That's just vinegar, making our food taste good and keeping it fresh. They're all around us, doing important jobs.
Okay, you are now an expert on acids. You totally get it. So what about the other side of the story? Let's flip the coin and move on to Section 2, the basics of bases.
And guess what? Just like we saw with acids, bases aren't all the same strength either. You've got your strong bases like sodium hydroxide, which you have to be really careful with because it's super corrosive. And then you have your weak bases like ammonium hydroxide, which are way milder.
So what are the dead giveaways that you're dealing with a base? 3 things to remember. 1, they taste bitter. 2, they feel slippery or soapy to the touch. And 3, and this is a big vocabulary word for the test, Venkat, if a base can dissolve in water, it gets a special name, an alkali. So all alkalis are bases, but not all bases are alkalis. It's just a special subgroup. Got it? And you'll find these guys all over your house, too. Sodium hydroxide, that's the main ingredient in soaps and drain cleaners. Calcium hydroxide, people use it in whitewash for buildings and to help out soil in their gardens. And this one's really cool. Ever taken an antacid for an upset stomach? You're actually using a base, magnesium hydroxide, to calm things down in there.
Okay, let's pause. We know acids are sour, bases are bitter. But we also know rule number 1 is don't taste anything. So we have a problem, don't we? How can we possibly tell them apart safely? There's got to be a better way, right?
And there is. The answer is to send in some secret agents. That's right, we have chemical spies that can figure out the identity for us. Welcome to Section 3. Let's talk about indicators.
So what is an indicator? It's basically a special substance that changes color when it meets an acid or a base. It's like a spy that changes its coat to send us a signal.
The most famous one, and the one you'll definitely see in your school lab, is called litmus. And fun fact, it actually comes from a plant-like thing called a lichen. Okay, this litmus test is super easy, but you have to memorize these two simple rules. Rule 1, if you dip blue litmus paper into an acid, it turns red. Rule 2, if you dip red litmus paper into a base, it turns blue. Here's how you'll remember it for the test, Venkat. For acids, just remember this. Acid turns blue litmus red. For bases, it's even easier. Base turns litmus blue. B for B. You won't forget that.
Now, litmus paper is great, but it's not the only indicator out there. Scientists have a whole toolkit. Two other important ones are phenolphthalein, which is a mouthful, I know, and methyl orange. They just give you different color changes. Phenolphthalein stays clear in acid but turns this bright, vibrant pink in a base. And methyl orange goes from red in an acid to yellow in a base. Different spies for different missions.
Okay, so the indicators are awesome for telling us if something is an acid or a base. But what if we need to know how strong it is? For that, we need something more like a ruler than a simple yes or no signal. And that ruler is called the pH scale. It's just a simple number line from 1 to 14. Low numbers, like 1 or 2, mean you've got a super strong acid. High numbers, like 13 or 14, mean a super strong base. And what's right in the middle? 7. pH 7 is perfectly neutral. That's pure water.
All right, Venkat, you're crushing this. We're on the final section. This is the big finale. We've studied acids, we've studied bases, so the ultimate question is, what happens when they actually meet? It's time for the main event. Section 4, all about neutralization in salts.
It's actually pretty amazing. When you mix an acid and a base together, they basically cancel each other out. It's called a neutralization reaction. The acid's properties disappear, the base's properties disappear, and you're left with something, well, neutral. And what are the products of this epic chemical handshake? You always get two things, a salt and plain old water. Check out the example. You mix a strong acid and a strong base, and what do you get? Sodium chloride, which is literally the salt you put on your French fries, plus some water. How cool is that?
And this neutralization thing, it happens everywhere, not just in a beaker. A bee sting injects acid into your skin, right? So you put a basic lotion on it to, you guessed it, neutralize the acid and stop the pain. Feeling heartburn? That's too much stomach acid. You take an antacid, which is base, to neutralize it. Farmers do this to their soil, factories do it to their wastewater. It's a super useful reaction.
Okay, one last super important point for your exam, Venkat. When a chemist says the word salt, they don't just mean the stuff you shake on your food. In science, a salt is the special compound that's created during any neutralization reaction. So yeah, table salt is one type. But baking soda? That's a salt too. So is washing soda, which we use for cleaning. Even the stuff used to make water clean, potash alum, is a type of salt. They're this whole family of useful chemicals.
And that's it. We did it. We went from simply tasting sour and bitter all the way to complex neutralization reactions. You're an expert now, Venkat. So I have a little homework for you, a fun challenge. Go on a scavenger hunt in your own house. What acids, bases, and salts can you find? I bet you'll be surprised how many there are. You are so ready for this exam. You're going to do great. And hey, do me a favor. Share this with your friends. Get them to listen too, so all of you can walk into that test knowing you're going to ace it. You guys got this. Good luck.